Okay, finally, a couple of extensions and other little pieces of information that you ought to know from this section. All right, ways that we have graphed so far. We started off graphing by just making x, y tables. Then when we talked about intercepts, we also learned that we could use intercepts to make a graph. And then finally in this section, we've also now used slope-intercept form. Take a look at each of these equations and see if you can tell what the best method is to graph each of these lines. Well, I bet you recognize this one. What form is this one in? Slope-intercept form. You could use an intercept of 5 and a slope of up 1 over 2 to graph that line. Piece of cake. This red one right here, that's in standard form, and it would be pretty easy to find the intercepts. Just set y equal to 0, 2x equals 12, so the x-intercept is 6. Finding the y-intercept is just as easy. Great candidate for x and y-intercepts. Taking a look at this third line, you'll notice it's not in standard form. Wouldn't be real easy to get x and y by themselves. Y is by itself, but not x. So really on something like this, since it's in function form, that'd be a great place just to make an xy table. Parallel lines. You'll know that two lines are parallel if they don't intersect. You'll remember that from elementary school. Keep in mind that slope determines the rate at which a line rises or falls, so that means that when you have two lines with the same slope, they're going to be parallel. That's how you know they're parallel. So let's see if we can determine which of these lines would actually be parallel. Let's see if we can figure out which ones have matching slopes. First of all, not all of these will have a slope that's easy or obvious to see. For example, right here, can you tell what our slope is? Well, y is not by itself. If we were to get y by itself, we could subtract x from both sides, and you could tell now that the slope is a -1. Let's see, where else do we have one like that? Over here, y is not by itself. You would have to subtract x from both sides. Pardon the handwriting here, writing with a mouse. And you'd have to go ahead and divide everything by -3. So the -1 divided by a -3 would be a +1/3. Now that we've got all that, let's see which ones we can match up. First line has a slope of 2. You can tell that's the number next to x. Therefore, this one would be parallel to it. They have different y-intercepts, but they have the same slope, so they must be parallel. This one has a slope of -1, and so does this line down here. Again, they have different intercepts, but the same slope. Now the x equals, well, that's a vertical line. What would be parallel to a vertical line? Bingo, another vertical line. This one has a slope of 1/3, and as we determined right here, so does this line. It wasn't obvious from the first form, but by the time you get y by itself, it should be obvious. And then finally down here, well, what kind of line is that? That's a horizontal line. What would be parallel to a horizontal line? Yep, another horizontal line. So how do you determine if lines are parallel? You know they're parallel if they have the same slope.